How about now? Better? Excellent. Excellent. Great. Well, thank you for coming. I'm pleased to be here with the Walgreens Boots Alliance team. We've heard some great stories today already in the keynote session, and looking forward to the session this afternoon. By way of introduction, my name is Eric Thorson. I work for Hortonworks. I manage the Retail and Consumer Products Group. This is a vertical industry team that we have here that we focus on distinct industries. I'm proud to work with retailers globally, and I've spent some time with the team in Chicago. I've spent some time with the team in the UK as well on the Boots side. And I'm seeing incredible opportunities for retailers globally in things like digital, in things like single view of the consumer, even in areas like inventory optimization, pricing optimization. All are wonderful areas to leverage open source data management in a creative way to drive retail success. What that means to the retailer is expanded revenues through larger basket sizes, protected margins by mitigating markdowns, and of course consumers becoming more satisfied and more loyal, which is truly the hat trick of benefits for a retailer. So it's a great opportunity for me to work with organizations like Walgreens Boots, and it's a great opportunity to share some of the successes that I've seen. I'm going to pass control here, and we're going to take you through the journey, but I did want to take a few minutes and just say retail is exciting for us here at Hortonworks. We're thrilled and honored to have Walgreens Boots as a customer, and really looking forward to a continued journey of success as we see great opportunities to continue leveraging this open source data management platform to drive impact. So without further ado, AB, I'll turn over to you, and you guys can do some introductions and take us through the journey.
Sure.
So thanks for coming.
Thanks, Eric, for kicking it off for us. And thank you, everyone, for joining us. It's late in the evening. Wasn't expecting such a huge turnaround, but I think Eric assured that we'll have some quite bit of audience once they know it's Hadoop and Walgreens, right? So quick introduction, my name is AB Koshi. I lead one of the data and analytics team within Walgreens. If you were part of the keynote presentation that our leader, Gauri Salka, did, it's a perfect segue into what we're going to present today, right? It's basically, this is the data complexity or the data ecosystem that we have within Walgreens, right? It's pretty complex in the sense that we have close to 900 million prescriptions that are filled annually. Apart from that, we have 87 million loyalty member customers, right? Apart from the prescription transactions that are filled on an annual basis, there is also retail part of it, right? There's the sales of retail products. That's accounting to close to 10 million transactions per day. We send out push notifications in form of campaigns and refill reminders. That accounts to close to 1.5 billion transactions on the system. On top of all of that, we have like 1.3 million connected devices enabling all of these transactions for us, right? So it's truly representing the three big V's of big data. You have data at scale, representing the volume. Also the velocity at which these transactions hit the systems. It could be batch, real time, near real time. It's variant in velocity, and you have variety of data. You have data sets in form of XML, batch feeds that comes into the system. So 3 years back, we tried to solve this by hosting all of these complex data sets into the enterprise data warehouse in an appliance form, right? Churning all of these transactions, this huge volume, just the power of the appliance, 80% of it was used in transforming the data set, making it normalized, cleansing it, right, and bringing it into the data warehouse. It was not truly used for its true capability for the analytical need, right? So only 10 to 15% of the system was used for true consumption. So you always had a system that was running at full max capacity, and the end users were not able to use it according to the desired capability of the system. And at the same time, you had the data sets that were constantly delayed. By the time they had the batch feeds for consumptions, it was delayed by a day or two. Around the same time, we had a critical business need that required like personalization. This required close to targeting emails for 87 million loyalty member IDs on a weekly basis. And this had to be done by churning the data sets across 87 million loyalty member IDs, churning through the 10 million transactions on a daily basis. You have a system that is already constrained. When you want to run a model where you want to scale and assign a scale to a customer that ranges from 1 to 5 based upon the recent transactions that he purchased, the recent transactions on products that he purchased, the frequency of the product category that he purchased, and the monetary value that it brings in. It used to take like close to 4 to 5 days to get the output from those models because the system was already taxed. Here is where we saw the opportunity, right, to introduce Hadoop and to offload some of the data set into an Hadoop ecosystem. We got all of this data set, stood up a small cluster, straight away brought the data set from the Enterprise Datawarehouse and ran these models. And it was only used for analytical consumption. We saw immediate value where the model, which used to run for 4 to 5 days, now it's coming back close to like in 4 to 5 hours. We were able to target emails to these customers at an intraday level, right? So immediate value that we saw with this approach. This is how basically we did it. Still the data came through the enterprise warehouse. We scooped the data out of the RDBMS, put it into the HDFS, and have the end users consume it from the HDFS for running their models. The category affinity that I just described is one of the use cases, but there were many other models that tagged on to the data set that was available in the cluster. Now, while we were doing this, we already had a vision and a strategy in place to bring in the raw data sources as much as possible into the lake, right, wherever possible. On the data sets that were historical and that required to be retained in the RDBMS for 2 years because your OLTP systems cannot retain that 2 years worth of data, we had a mandate to bring it from the RDBMS into the Hadoop system. But any new sources, any new ingest that we wanted to get it, we did get it directly from the source into the HDFS. This is how the model was built. Basically, we used Hive to do the data extract, to do the data cleansing, and we used Pig and MapReduce to do the model scores. Once those model scores were retained, we pushed it back into an Hive layer, right? This was completely a single platform, and all of the workflows were scheduled using Uzi. These are basically like the tool stacks that we use from what we had from HDP. So really an opportunistic approach. It really gave us a quick turnaround. We were agile in fashion to respond to that business need. We delivered immediate business value. And 3 years back, doing Hadoop and the tool stack that comes along with HDP, it was considered to be cutting edge, right? So we increased employee satisfaction. We also retained a lot of new talent. We retained a lot of talent and also attracted new talent because we were doing Hadoop. However, the cons for this, we had a lot of data duplication. We routed the data set from the source systems into the warehouse. From the warehouse, we scooped it out, brought it into Hadoop. So there were like multiple data hops, data duplication. And since we were always dependent on an RDBMS system that was fully constrained and taxed, by the time we got the data, it was considered to be out of sync. It was not matching 100% to what we had in the source systems. So this also gave us added business value and added making our strong case to the leadership on the need of hosting the data and having a centralized data warehouses or a data hub, right? We implemented this using Hadoop, right? And this is how we laid out the architecture. Basically, what you have is source systems directly feed into the Hadoop IDH, both in batch and real time. And the layer where it comes into, right, it was logically separated. So you have data in its raw form from the source systems land into the raw layer. From the raw layer, it is moved on to the cooked or the semi-cooked layer, and from the cooked layer, it is moved on to the served layer. And from the served layer is where you have your consumption enabled for your APIs, for your BI dashboarding, and so on, right? So these different layers were all logical, but it was still persistent inside the HDFS. Now, while we did this, we ensured that we had proper governance, we had proper security in place, we had metadata collection enabled, not only at the job level, at the operations level, but also from a consumption and from a business perspective. So this is how we segregated the data for its purpose. So we used HDFS primarily for initial exploration, data preparation, unstructured analysis, streaming. RDBMS still found its place for doing interactive SQL responses, right? And also for BI and dashboarding. When we did IDH, I don't think the intent was to replace any of the RDBMS or any of the existing capabilities that we had. It was to augment to what we already had in the ecosystem. But at the same time, to be cost effective, we wanted to reduce the footprint as much as possible onto these systems. Based upon the temperature grading and how it's utilized, how the data sets are utilized, we categorize them into hot, cold, and raw data, hot and cold data, and then based upon the variety and the type, we categorize into raw, structured, and unstructured data. And based upon these categories, we bucketed them into different layers, into HDFS, RDBMS, and NoSQL. We primarily used NoSQL for augmenting some of our ETL processes inside HDFS, and also for API consumption. So this is a summary of what the benefits that we had using Integrated Data Hub, which we are seeing already and which we want to mature on, right? This is in process by faster processing and agile analytics, providing active archiving. In data by implementing better security and governance, and reducing silos. Platforms, we had better platforms solving the 3 Vs, being cost effective, reducing the footprints on the RDBMS as much as possible, and having the system being self-serviced and self-enabled, right, for the end user consumption. Obviously, we attracted a lot of talent because of the technology that we were doing. And communication, as part of communication, it always, it improved in the sense that we were able to get interactive user responses because of this platform. With that, I'll hand it over to Gupta, who's our DevOps partner. And truly, this journey is about collaborating and moving beyond the org boundaries, how the teams came together. We were on the application side. We worked closely with the business, whereas Gupta and team, they were part of the infrastructure team who implemented the Hadoop from like the hardware, software administration perspective.
Good afternoon, everybody. Can you hear me?
Move it up, move it up.
Hold up. Can you hear me now? Okay, good. Good afternoon. Thanks, AB, for the introduction. So my name is Gupta Narayanam. I've been at Walgreens for the past 3 years. I'm a Hadoop architect, building and administering the Hadoop clusters at Walgreens. So AB talked about from the application and a business use case perspective. So I'm going to take you through our infrastructure journey. So we have started our journey around 3 years ago. We started small. We went live with 14 nodes in production. And we started with HTTP 2.1 software, which was the latest at that point of time. Then we moved on to, within 6 months, we expanded to 29 nodes. And during this period, we also have done LDAP integration. So this is a game changer for us. prior to integrating Hadoop with LDAP, we had 3 different username password combinations to use 3 different Hadoop components. Like, for example, when the users log on to the Linux machine, they need one username password. To log on to Hue, there's a different username password. And to use the Kerberos, they had to use a different username password. So after integrating LDAP, we were able to use the single sign-on process of Walgreens Enterprise. So it was much more easy and streamlined for us to onboard new users onto the platform. And it's also easy for users because they don't have to remember different username and passwords. And in Q3 2015, we did a major upgrade from 2.1 to 2.2. We also did a major expansion of our cluster to 62 nodes. By this time, the users started seeing the benefits of the Hadoop platform. So they wanted to onboard more use cases. They wanted to deploy more jobs onto production cluster. So they needed basically more horsepower. So in order to meet the demands of the user community, we bought more servers and we added them to our production cluster. And in Q1 2016, we did another major upgrade to HTTP 2.3. And in Q4 2016, this is another game changer. As AB had talked earlier, initially we took the opportunistic approach 3 years ago. We wanted to get a use case that can get us a quick win, and we proved that Hadoop platform works. So now we started taking more strategic approach, building the system for the future, which means we wanted to go and get the data from the source systems directly into the Hadoop cluster. But it resulted in we having 2 different clusters. So now we are taking an initiative in decommissioning the old cluster and moving everything to the IDH. So that project will be done by the end of Q3 this year. And in the first quarter of this year, we did like a HTTP 2.4 upgrade. And in the second quarter of this year, we did a new cluster just for the HBase use cases. So we had 2 options. Either we can install and configure HBase on the existing cluster or build a new cluster. We chose the second option primarily because of the performance requirements and the read and write latency requirements of the HBase use cases. We thought it's a good idea to separate it out, where we can buy different hardware with SSDs, and we can configure the system more efficiently and more performance-oriented. And we are in the process of ramping up at Walgreens. By the end of this year, we would be reaching around 300 nodes. So we are on this upward momentum, and I think this momentum would carry on, and more use cases would be brought on. I think the future is going to be pretty exciting. So let's look at the cluster physical architecture. So this picture has 3 parts. I'll walk you through one at a time. So let's focus on the right-hand side of the picture. So this is a closed VLAN where all the master nodes and the worker nodes are placed. And we have enabled the rack awareness feature of the Hadoop system. All the nodes are placed in different racks. So basically what is rack awareness means, right? When the data gets ingested into the Hadoop cluster, the system makes sure the 3 copies of the HDFS blocks do not end up in one single rack. So that means even if a rack goes down because of a power failure or some other catastrophic event, the system can still continue to operate with a reduced capacity, but the users can still run their jobs. Also, if you noticed, we had split the master nodes between the rack 1 and rack 2. So for example, if an active name node is running on rack 1, then we would have a standby name node on rack 2. So even if the rack 1 goes down, the system will still have enough master nodes to continue to operate. So this is a fault-tolerant system that we have built in our data center. On the top of each rack, we have a network switch, so that has like a 10 gig capacity. And the top of the rack switch is connected to a core switch that has 40 gig capacity. These switches enable a faster network data transfer across the different nodes in the Hadoop cluster. So now let's move on to the middle part of the picture. So this is, again, another closed VLAN where we have an edge rack. So the edge rack contains the edge nodes, or we can also call them as Hadoop client nodes. So this is where all the Hadoop clients are installed, and this is the entry point for the application teams and the business teams. The edge rack also has a couple of management nodes. These management nodes contain the web server components of the Hadoop ecosystem. Some of the examples are like Ambari server, Uzi server, Ambari views, and Ranger. So these are all the web components. So we wanted to have web components in a separate network zone. We don't want it to have them where the data is actually residing. So that's why we have placed a firewall between these two zones in order to meet the security standards of the Walgreens enterprise. Now, if we look at the leftmost part of the picture, these are the different ways that a user can access Hadoop cluster. So they can use the most traditional way of SSH terminal access, or they can use browser, or they can use tools like Tableau or business objects and use the ODBC connectivity to connect to the Hadoop cluster, or they can use the REST APIs and connect to the Hadoop cluster. So let's move on. So in this slide, we are trying to show the high-level workflow of how to build a cluster. As you can imagine, there will be several teams that need to be involved and work together in building a cluster. So this kind of shows the high-level workflow. So the application team comes up with a business use case, and they decided to use Hadoop to solve their business problem. So they make a request to build a Hadoop cluster. Then the Hadoop team collects all the requirements and does the initial analysis. And then they come up with the hardware and the server specifications that would be needed to meet the requirements. And then they submit a request to the server team. The server team procures the hardware. And once the hardware gets shipped into the data center team does the rack and stack of all the new machines. And after that, the server team will install and configure the operating system on top of those new machines. So while this is going on, in parallel, the database team is building new schemas to store the metadata for the Hadoop. So at Walgreens, we use Oracle as our backend repository. So those schemas are like for Hive, Uzi, Ranger. So those schemas are built by the database team. So once we have the database schemas ready and we have the servers ready, we can install and configure the Hortonworks HTTP software on those new machines, and then deliver this cluster to the application team. The application team does the sanity testing, and then they start deploying the production jobs into the cluster. Okay, let's look at some of the lessons that we have learned over the past 3 years. So involve all the teams ahead of the time. So this is a very important. So I just briefly highlighted some of the teams that were involved, but I didn't highlight many other teams that need to be involved. Like, for example, we need to work with the firewall team. We need to work with the security team. We also need to work with the identity and access management team for creating all the system accounts. So there are several teams that need to be involved. So it's a good idea to give a heads up and bring all the parties together before you start the process. So during the build process, if you run into any issues, we can have a quicker turnaround time because all the teams were involved ahead of the time. There are no surprises, right, actually. So the second point here is implement security from the beginning. Adding Kerberos and LDAP integration later caused migration issues. So it's always a good idea to implement security from the day one. Because we have integrated LDAP a little later in the process, so that had caused some issues like users have lost their saved queries, and then they have lost their data in their HDFS home directory. So we want to avoid all of that. So if you're building a cluster now, we would recommend you to implement Kerberos and LDAP from the day one. So the third one, this is an important point. So educate the user community about the caveats of open source products. So traditionally, the application and business teams were used to more traditional systems like MPP systems like Teradata or Netezza. And those systems, we don't upgrade it frequently, right? So they don't need frequent upgrade cycles. However, Hadoop is like an open source product, and the rate of innovation is too high. So we are getting features at a much faster pace. So we needed to upgrade the systems more frequently, which could result in downtimes and maintenance cycles. And also one thing to notice is because it's an open source product and it's a fast moving train, it also introduces a lot of bugs into the system. So you should be ready to patch your system more often with hot fixes. Hortonworks is good at supporting us with hot fixes, but you have to educate the users that you need to be more agile and be ready for more maintenance cycles, actually. So. And another point is involve Hortonworks ahead of time for HTTP upgrades by sending the Ambari database backups for review. So this had helped us in some instances where Hortonworks was able to review our database ahead of time and gave us update scripts, and we were able to run those scripts prior to the upgrade so that the upgrade process went quite smoothly and quite quickly. So initially, we didn't follow this process, so that's why the upgrades had taken much longer, and we ran into many more issues. But the recent upgrades, we were able to do it much more quicker and much more smoothly with the collaboration with Hortonworks. And one more thing I wanted to say is make use of Hortonworks SmartSense. We have enabled the SmartSense in our clusters. Basically, what it does is it collects all the configuration and all the log information from your cluster and makes it a bundle and uploads it to the Hortonworks for review. And the Hortonworks does a review of those configuration settings, and then they send back us the recommendations, and we review those recommendations and apply them. A lot of times those settings help in fine-tuning the cluster and in improving the cluster performance. So we do recommend to use the SmartSense, actually. So that's all I got. So any questions for AB and myself or Eric?
Yeah, we've got a mic. We can come around and get questions.
So I've seen you have sort of DMZ for your edge nodes. Have you looked into Knox, or any reason where you didn't go with Knox?
No, we are doing a POC with Knox. We would pretty soon go with Knox, actually. So.
No, we are considering Knox for perimeter security. That is something that is strongly recommended even from our security teams to put it in place. We do have to do benchmarking because of all the apps. We have both traditional and the new in terms of SOAP and REST that is coming up. So integration of all of those apps along with Knox is something that we would have to evaluate internally. But we are considering Knox as a security feature.
So to add on to that, so some external tools, we are checking the compatibility. So for example, we use SAS. So we have to make sure that the external vendor supports Knox before jumping onto that bandwagon, right? So.
Yeah. How are you handling updates in Hadoop?
How do you handle updates?
That's your question, right?
No, it's, I think you're referring to Ambari upgrades or Hortonworks? Oh. Okay, so let me repeat the question. So it's about performing CDC inside HDFS, right? Till now, what we've been doing is segregating and segmenting the data in such a way that you can partition, eliminate, and replace the entire partition, swap the entire partition. It is a cumbersome process. It takes a lot of CPU to do that because our updates range back to 11 years. You could have a prescription that is stuck in the system and doesn't clear up for like 5 to 6 years. So you would have to apply that update 5 to 6 years back, right? But recently with, I think, the newer release, the HTTP 2.6, they have enabled Hive ACID features. And we are evaluating Hive ACID for that capability for handling incremental updates. So just to repeat the question, so how many concurrent users you have on the Hadoop ecosystem? As I said, the phase 1 where we did the opportunistic approach, it was only one set of business unit. It was close to 10 to 15 business users that were on the HDFS system. Moving towards the integrated data hub, we are doing a lot of extracts and data feeds into system. We haven't onboarded end users yet. But the idea is to enable workload management, have them segregated based on queues, and have more and more end users directly or indirectly access the Hadoop system, right? A lot of users use SaaS, who come and extract the data out of HDFS, put it into SaaS, and then do their end user. So those users can be technically considered as the Hadoop users. Concurrency, I think it can be addressed by workload management and proper queuing using Yarn is how we see it, and we onboard more users.
From a infrastructure perspective, what's your cloud strategy?
So for now, the production systems are going to stay on-prem. So we are looking at moving the non-production systems like dev and QA to the cloud platform. So we did a POC, so pretty soon we will be making a decision to move to the cloud, only for non-production systems.
I think we have one more question.
For your production systems, do you have any sensitive data? And if you do bring anything, do you do any de-identification masking?
Yeah, that's a good question, right? So we are pharmacy, so you can imagine we deal with like the most secure data in HIPAA form, right? We have tools, checks and balances. We have governance in place. So there is an established governance already as part of Walgreens Enterprise that we segregate end users based upon their access or their roles and responsibilities, right? So we ported over all of those governance structures into the Hadoop ecosystem using multiple tools. It's not one set of tools. So we used Ranger along with like ACID, along with Hive roles and views that were implemented, right? Yeah, I forgot the second part of your question. What was the second? Yeah, so we do use an external tool for encryption and tokenization of the data set, which is outside of the HDP tool stack, but they're close vendors or close partners, so it's integrated well for us. Also, what we are doing is evaluating the native HDFS encryption that is already in place to do some of the encryption and tokenization. Yes?
So you see you're moving a lot from the warehouse world. How are you guys managing data quality? Do you guys get additional tools, more command line? How do you guys address quality?
Yeah, so the question is again on data quality. How do we address data quality when we move from warehouse to Hadoop systems, right? Again, it's a lot of checks and balances. We have something homegrown that is in place that is generic in fashion regardless of the source system. We tap into it. We have the generic code, do basic checks on record counts, on data anomalies, on null checks, on the patterns, on trendings and reports like that, right? Along with that, we haven't used any external tool yet, but we are strongly considering evaluating some of the tools for data quality checks and balances. Along with pharmacy data, now we are embarking also financial information into the Hadoop ecosystem. So that is one of the primary requirements that we have, is to evaluate and implement data quality checks across the board.
So from the visualization perspective, I heard you guys saying you did not enable the power users into the cluster yet. So is it all through the database, which is the gold layer in front of the cluster? How do you do the real-time visualizations?
Yeah, so there's two different layers, right? So you have like the raw ingested data, semi-cooked, and that data set is exposed to only the power business users, right? So to the data scientist, they don't need visualization tools to explore the data and make sense out of it. They have hands-on skills to do that. For visualization, we have a BI tool in place that integrates very well with Hadoop, but what we found so far is integration of a BI tool directly into the HDFS or Hive does not perform like to the expectation. So you need an engine, some accelerator in between to facilitate that, right? There are multiple tools. Again, there was a strong partnership announced with one of the vendors, and we are considering one of the tools that the vendor provides. So far, the POC has been very promising. What we've seen the trend is these SQL accelerators, it can tap into the already existing MapReduce frameworks, and they can leverage the data sets that are already segregated into blocks and tap into those frameworks or come up with similar frameworks, get access to the data and accelerate for BI purposes.
So then the extracts from the lake into your database or gold layer, is it a batch? Is it daily, or what is the frequency?
Yeah, it is in a batch fashion. So we do some augmenting there is by extracting the data out of the HDFS, rolling it up, aggregating, and creating like core aggregate sets for your visualization tools.
Thank you.
Yeah.
So I think you're describing some of the capabilities of at scale, looking at the analytical tools, having the interactive experience, right? Have you done some POC between at scale or Druid? See how you can have cost over performance?
Yeah, so I think our teams have got a nickname of being like the POC teams for the past year or so. We've been heavily involved in doing a lot of POCs because this is one area where we see definitely a challenge is like SQL on Hadoop or interactive response on Hadoop. At scale is definitely one thing that we looked into. One of the challenges that we got from at scale was it required data sets to be aggregated and pre-built into cubes, which would require a refresh on a daily basis. So it did not cater to the use case that we were looking into at that point in time, but I'm sure it has evolved from the time that we looked into. And there are other tools also which are very promising, which is delivering the capabilities for the use case that we are looking into.
I noticed you guys scaled up quite quickly in the last in a year or two.
Yes.
Since it's on-prem, how did you guys handle that? What was your turnover? Can you just talk about the strategy and how you guys scaled?
Yeah. So very good question, right? The fastest rate of our data center being consumed is like the Hadoop nodes that is being installed for the past couple of years. We established like a core team and facilitated all of the work that is Hadoop related to a set of teams. We identified the teams who did it and implemented it for the first time, and we retained the same team going forward. So as Gupta was explaining the workflow, from the inception of placing a purchase order with the vendors, rack and stack, shipping it to the data center, and laying those clusters out, we have a dedicated team. Now they are experts in that. We are also looking into a lot of automation that is coming up in the form of Chef we have some of the cookbooks that are already ready that can implement like the OS level and the config level changes across the cluster. Be it 20 nodes or 60 nodes, it's just one cookbook applied across the nodes.
Okay, I think they're giving us the sign. It's time to be done. We'll close down the equipment, be available for Q&A after this, but thank you very much for coming.
Sure, thank you.
Thank you.